Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 talks about hydrogen bromide. Part A is to draw the Lewis structure. B, report the number of bonding electron pairs on the bromine atom. C is to report the number of non-bonding electron pairs. D, report the total number of electron pairs on the bromine atom. E, name the electron set distribution. F is the geometrical shape for the diatomic molecule. And G, make a model of the molecule and sketch a 3D model below using dashes and wedges where necessary. Okay, so hydrogen bromide. And to draw out the Lewis structure of hydrogen bromide, we first need to calculate the total number of valence electrons in the molecule. Hydrogen has 1 valence electron, and bromine has 7. And there's only 1 of each, so we just need to add these two together to get a total of 8 valence electrons. So now we just need to draw a single bond from hydrogen to bromine, like so, since there's only these 2 elements. And we can also show all of the lone pairs on our bromine as well. So if we recall that each bond contains 2 bonding electrons, and we also have 6 electrons in the form of the lone pairs, then you can see we already have our 8 electrons that are needed for the structure. So this is part A. And for part B, we need to report the number of bonding electron pairs on the bromine atom. So we have 3 electron pairs. And for part C, report the number. Okay, so part B was the bonding electron pairs. So actually, it's just the 1 hydrogen atom. So we have 1 bonding electron pair. So this is the hydrogen. And we have 3 non-bonding electron pairs. So these are the lone pairs. D is to report the total number of electron pairs. So we have 4 if we add those 2 together. And E says to name the electron set distribution about the bromine atom. So one way we can do this is to look at a Vesper theory chart. So since we know the number of bonding electron pairs and non-bonding electron pairs on our molecule, a Vesper theory chart can tell us the molecular shape it is expected to have. So if you look at the first row, or the very last row here, when you have 1 bonded atom and 3 lone pairs, then the molecular shape is linear, and the electron geometry is tetrahedral. So let me see which one was first. So the electron distribution is tetrahedral. And F is we have a linear molecular shape. Okay, so G is to make a model of the molecule and sketch a 3D model below using dashes and wedges where necessary. So let's try to draw a 3D model. Maybe I can fit it on the right here. So let's say we had bromine as our central atom. I can draw my hydrogen like this, and then also show all of the lone pairs in a tetrahedral shape. It's kind of roughly should look like that. Okay, so now let's see what the junior tutor said. Step 1 is to list the elements, their valence electrons, and determine the total valence electrons. If a charge is present, add the value of the charge to the total valence electrons when it's negative, subtract if it's a positive charge. So we have a total of 8. Step 2 is to draw the skeletal structure, and note that one bond consumes 2 valence electrons. Okay, so they drew only the single bond and wrote 2 out of the 6, and for the remaining 6 they put on the bromine. For part B, there's 1 bonding pair, C 3 non-bonding pairs, D 4 electron pairs. E we have, I think they meant to say tetrahedral electron distribution, and a linear geometrical shape, and they drew out the structure. So I'm just going to say that most of this solution is correct. The electron geometry is tetrahedral since we have 1 lone pair and 1 bonding atom or bonding pair and 3 lone pairs. And then I'll just mention that the 3D model will show a tetrahedral shape and bond angles of 109.5 degrees between the 4 electron pairs. Yep. So we have sp3 hybridization.